Fun Sock Friday, most lit day of the week, the 16th of April. Yep, we're just looking at Bill right now. So you guys will be able to define and identify rectangles, rhombi, squares, and find measures of those shapes. Section 8.4. So we spent last class doing those note cards for these first four shapes. Parallelograms, which we covered in 6.3. We knew those shapes pretty well at that point. Then we did rectangles, squares, and rhombi. And this was our way of learning these shapes, okay? Learning some things about them, some characteristics, some definitions of them. And then earlier in this class, just a moment ago, we went ahead and did the finished the note cards, or mostly completed the note cards, I should say, for kite, trapezoid, isosceles trapezoids. We're actually going to set those three shapes aside that we just did today, okay, in the GeoGebra activity, for later. And we're going to focus on those first four, okay? Parallelograms, rectangles, rhombi, and squares. Now, what I want you guys to be able to do is to be able to differentiate between them. To say, hey, I know this about this shape, but this isn't true for this, but this is true for these two. Oh, a rectangle is also a parallelogram, but it's not always going to be a square. So on and so forth. So, in these examples, I want to know what's the most specific name that we can give for the quadrilateral. So, this first one, it's a quadrilateral, four-sided figure. Raise your hand if you think you know the most specific name for it, and give me some supporting evidence. Okay? Let's go with Liam. I saw your hand up first. Okay? Now, Liam, why do you believe this is a rectangle? Okay, so it has all 90-degree angles. And what's our definition of a rectangle, guys? A parallelogram with four right angles. Four angles that are 90 degrees. So does this fit that description? Now, do we think it's quite enough to say that it's a square?
No.
No, why not?
Because not
all four sides are congruent. So I would agree that the most specific name that we can give to this is a rectangle. Now, is it also a parallelogram? Yeah, but a rectangle is going to be more specific because this is another type of that, okay?
Isn't a rectangle a square?
No, but a square is rectangle.
So a square is a type of rectangle. A rectangle can be a square. Alrighty, what do we think the second one, the top right one is? Bill?
Parallelogram.
Okay, why do you think it's a parallelogram? Give me your supporting evidence.
Because Aiden said so.
Okay, because Aiden said so. Okay, well, Aiden, why do you think it's parallelogram then?
Because the four different types of lines, congruent lines that show.
Okay, so we know the sides aren't all the same length, but there's two pairs of congruent sides, right? The opposite sides are congruent, but do we know all four sides are congruent?
No.
No, so we can rule out rhombus, and what else can we rule out?
Rectangle.
Square. Now, how can we rule out rectangle, Max? Because of the angles. We don't know anything about them, do we? They don't look like they're right angles, but we don't know one way or the other, so we can't say they are. So I would agree that the most specific name for it is parallelogram. Any questions on that one? Okay. That third one, middle left. What are we thinking for this one? Raise your hand. Okay, Gage, what are you thinking?
A rhombus.
Okay, give me your supporting evidence for it being a rhombus.
Because the opposite sides are parallel for the angles and stuff. And all four sides are congruent.
Okay, all four sides are congruent, so we know it's a parallelogram, and specifically it's more. So we're going to be more specific type because all four sides are congruent. So if all four sides are congruent, that drops it down to two of them, right?
Yeah.
It drops it down to rhombus and what else? Square. So what's our proof for why it's a rhombus instead of a square, Gage?
Because a square has right angles.
A square has right angles, and do we know these angles are something other than that?
Yeah.
Yeah, we do. So it would be a rhombus. I would agree with that. Okay? Questions on that one? Aiden, do you have a question?
No.
Okay. On this third one, raise your hand on this third one if you want to give your statement and your supporting evidence. Okay, Kaya.
I think it's a rhombus.
Okay, why do you think it's a rhombus, Kaya?
There are two pairs, both pairs of the opposite sides are congruent.
Okay.
Both pairs of opposite. I meant angles,
Okay, that makes more sense.
and then both pairs of opposite sides are parallel,
Okay.
and they bisect each other.
Okay. The diagonals bisect each other. Both pairs of opposite sides are parallel, and opposite sides are congruent. Now, are all of those things true about any parallelogram, though?
Yes.
They actually are. So Dominic was saying a little more specific here. What do we know that's specific to the diagonals of a rhombus here? The diagonals are perpendicular to each other. So that's actually the only thing here that we have that's specific to a rhombus. But I would agree that it is a rhombus. And the only reason we know it's a rhombus rather than something else is because of those diagonals being perpendicular. Every other piece of information here is true about any parallelogram, actually. Now, I do want to notice this is a little confusing on this shape, but the angle with the white opening and angle with orange opening, those would be two different measures, right? That'd be equivalent of using one arc and two arcs there. That's what that's getting at, in case there's any questions on that. Continuing on. This bottom left one, raise your hand if you want to state what it is and why. Okay? Sarah, what are you thinking?
I think it's a rectangle
Okay, and why do you think it's a rectangle?
because both the all four of the sides are the top two are parallel and the side two are parallel.
Okay, so both pairs of opposite sides are parallel. What do you say after that?
We don't know any of the angles.
Okay, we don't know what are the angles. So wait, what's a rectangle then? You said you think it's a rectangle.
4 right angles.
Okay, a rectangle has to have 4 right angles, but you just said we don't know any of the angles. So can we confidently say it's a rectangle if we don't know any angles?
No.
That means we can't say it's a square.
That means we can't say it's a square either if we can't even say it's a rectangle. Okay. Okay, oh, there it is. It has to be a parallelogram. That's the most specific we can get. Now, does it look like it's a square?
Yes.
Yeah.
Sure, it looks like it, but do we know it is?
No.
No, we don't know it is. What we know is that it's a parallelogram. It could be a square. We don't know. Any questions on that? Okay. The very last one. Aiden, what are you thinking?
Square.
Okay. Aiden, give me your evidence as to why you think this one's a square.
Because they have a congruent side and 4 right angles.
Very good. That's exactly right. That's actually even the definition of a square. It has 4 congruent sides and 4 right angles. It's a parallelogram that has that. So this is, in fact, a square. Do you notice that also the diagonals are perpendicular, like a rhombus would have? And a square is a type of rhombus, just like it's a type of rectangle, okay? Any questions on these 6? All right, if you flip over your page, you have a mostly blank page. What's it say on the side? Graphic organizer. Tip the page to where the graphic organizer part is at the top. We're going to make a family tree, so to speak. Okay? Okay? It's actually going to start above parallelogram.
Circle.
Polygon.
Below polygon, between the two.
Circle.
Quadrilateral. We're going to start with quadrilateral. So we're going to say inside, we're going to start with our quadrilateral. So let's say we have a quadrilateral, a 4-sided polygon. That's all a quadrilateral is, a 4-sided polygon.
Well, polygons or silicon?
Is it a boy or a girl?
Oh, both.
Default.
Sure.
It's a hermaphrodite.
Then, what is a more specific type of quadrilateral, but not incredibly too specific?
Parallelogram.
Parallelogram.
This is a weird tree.
Yes.
Bro, who names their kid parallelogram?
This guy?
Where are the divorces, man? They're supposed to have some divorces in there.
Oof.
Yeah. It's
I mean, you're never supposed to have divorce, just so we're clear.
Like, come on.
Where's the mom?
I'm going to fundamentally disagree with that.
Yeah, I get it.
Okay. Now, what's a more specific? What do we think might fall under parallelogram?
Square.
Square and rectangle.
No.
Rectangle is going to be one of them. And you guys are correct that the other one over here would be a rhombus.
Rhombus.
What do we know to be true about a square?
Bro, how are they reproducing?
They're a rectangle and a rhombus.
It's a rectangle and a rhombus.
Oh.
Incest.
Oh
Yo.
my god.
Kaya, we didn't
PDA. Oh my.
Okay. So what I want us to know, what I want us to take away from this is to be able to kind of see if we find any shape, it's everything that's above it. So a square is also a rectangle, rhombus, parallelogram, quadrilateral. A rectangle, is it always a rhombus?
No.
No. The only time a rectangle is a rhombus is if it's a square. Otherwise, a rectangle is a parallelogram and a quadrilateral. Is a rhombus always a rectangle?
No.
No, is it sometimes a rectangle?
No.
Yes.
Yes, in which case it is a
Square.
Okay, but a rhombus is always a parallelogram and quadrilateral. Is a parallelogram always a rhombus?
No.
No, sometimes. Is a parallelogram always a square?
No.
No, sometimes. Is a parallelogram always a rectangle?
No.
No, sometimes. Is a parallelogram always a quadrilateral?
Yes.
Yes.
Yes. Does that make sense?
Yes.
So everything is whatever it is above it, sometimes what it is below.
That's not a sturdy tree.